Hey students, it's Mrs. T, and in this video we are going to talk about the hydrosphere. So we've already begun this topic in the previous lessons about heat transfer and the atmosphere and water vapor and the changing state of matter, including water, from solid to liquid to vapor. And so all of that previous knowledge that you've gained in the lessons up till now contributes to your understanding of this chapter, which is chapter 9. Let me make sure I'm telling you the truth. Yes, chapter 9 in the 12th edition. Remember, that's the edition that I'm looking at. But the title of the chapter is the hydrosphere. So make sure that whatever edition you're using, you look at that particular chapter. So the hydrosphere, of course, is one of the 4 spheres that we focus on in physical geography. We've really hit hard and heavy on the atmosphere, which of course included a lot of the hydrosphere so far. And we're going to focus solely on the hydrosphere as it relates to the other spheres in physical geography this week. And then in the following weeks, we're going to look at the lithosphere and plate tectonics and all that kind of stuff. But for the next few sets of lessons, we're going to be looking at the hydrosphere, various elements of the hydrosphere, and the cryosphere too, which is about permafrost and the ice that exists on the surface of the Earth. So those are some key terms, hydrosphere and cryosphere. And the first thing that you will read about in our chapter is the hydrologic cycle. Now, we've talked about quite a bit of this already with the evaporation or the deposition or the condensation or the sublimation processes of water and the heat transfer system. But in this set of lessons, we're going to look specifically at how the water cycle works from the ground to the atmosphere, like we've talked about so far. So in this graphic that's behind me on the screen, you can see that we're looking subterranean here at the way that water behaves in the earth, within the earth, and not just in the layers of the atmosphere above it. So groundwater is a focus of this particular chapter. And you will, of course, groundwater includes water in lakes and streams and ponds that is visible to us. But there are also quite a lot of bodies of water that are subterranean, below the Earth's surface. And collectively, we call those groundwater. There is groundwater. There is a water table. If any of you have ever sunken a well on your property, you have to know where the water table is, and you sink the well down below that in order to bring up groundwater. I live close to the Arkansas River, and several years ago there was a water project. I don't know the official name of it. I think it's the Biomedo Water District, I think is the official name of it. But there was a water project, as my family and I called it, close by, where they built a canal. Engineers with the government and the Corps of Engineers built a canal from the Arkansas River all the way to Stuttgart, Arkansas, to fill up the aquifer that is there. And aquifer is something that exists as part of the groundwater system. And in Stuttgart, agriculturally, rice is the king in Stuttgart, and you need a lot of water to have proper rice production. And so the aquifer has been depleted over time, and this was an effort, building this canal, which I think isn't complete yet. I think it's not quite finished, the canal all the way to Stuttgart. But building this canal was a project that was proposed, if I'm not mistaken. I'm going off memory here. I haven't looked this up before I'm making this video, so I might be wrong with my dates, but I believe it was back in the 1950s that it was proposed that a canal be built from the Arkansas River to refill the aquifer. And a conglomerate of farmers got together to sponsor this. And anyway, the rest is, of course, history, but physical geography history, where we are trying to manipulate the water cycle because of our agricultural use in the area, right? So there's a lot of different bodies of water, in addition to rivers and lakes and streams that we can see, that run underground. They literally flow underground, as you can see in this graphic behind me, that demonstrates that water from lakes percolate down through. This word percolation is one of our key terms. They percolate down through the rock and earth layer into literally bodies of water and pathways where those waters flow from lakes and rivers, not just rivers like the Mississippi River. You might be familiar with the geography that the Mississippi River flows toward the Gulf of Mexico into that salt water and then out into, of course, mixes in brackish water and in the in bays, etc., into the Gulf of Mexico, and then becomes part of the ocean water, and through that cycle, and becomes part of that cycle of currents and tides and upwelling, etc., in the oceans. So yes, mixing happens that way, but as you can see in this particular graphic, groundwater also enters into freshwater. In other words, enters into the saline conditions of the ocean through the ground. In a lot of cases, there are springs and upwelling that have been observed on the ocean floor, in the Mediterranean, in the Caribbean, in the Gulf. These kinds of things occur. And so there is a constant transfer. The water cycle here, hydro, of course, means water, and the cycle is the process of mixing and sharing. There's water in all states of the atmosphere and in the earth. And so it is vitally important to understand the movement and the flow and the sources of this water, because there is no more water now than there ever has been in the past, and there won't be any more water generated or created in the future. It's just that water is in various stages. So this chart behind me demonstrates or reviews some of those various stages I'm referring to. So, of course, there is the liquid form of water. This doesn't really give you a whole lot of a picture of the solid form of water with this little snow-capped mountain behind me, but it also has the vapor form of water represented in these clouds that we've learned about recently in our lessons. And so, of course, condensation happens, precipitation happens, transpiration happens. These are all words. I'm rattling them off for you because you should have them in your notes already from previous lessons. But this graphic, similar to ones that you've seen in your textbook, demonstrates that cycle, the process of flow and transfer of energy that occurs when water moves from one state to the next, and then also has literal movement from one place on the earth to the next, not just one position in the atmosphere toward the earth, but in a circular motion in the earth. This next graphic, let me move myself out of the way here. This next graphic shows you that we have something we differentiate in the water cycle between the large water cycle, which is that percolation and groundwater flow, and the small water cycle, which is the evaporation, condensation, clouds, condensation nuclei, precipitation, snow, this kind of thing, the flow of rivers, surface flow, for instance. And so this graphic is very similar to the previous one with the similar information, but shows that you can differentiate between the large water cycle and the small water cycle with the different processes that exist. The small water cycle is part of the large water cycle, but in this chapter we are turning our eyes to the oceans again, to ocean currents again, and also to groundwater, such as the aquifers that I mentioned, underwater streams and rivers. You can even think of cenotes, water-filled cenotes in Central America as part of the groundwater cycle. If you've sunk in that well, for instance, you can about the importance of understanding the the water table and the level that the water usually is in your neck of the woods, the subterranean level where the water usually is in your neck of the woods. Okay, and so let me see, I have one more thing. Yes. Oh, yes. So this is a word that I mentioned briefly. I think not since the first couple of weeks of class have we talked about the cryosphere, and even then it was very brief. But the cryosphere is part of the water cycle. It's part of the hydrosphere, so it's kind of like a bullet point underneath it. That's how you can list it in your notes, actually. The hydrosphere has the cryosphere within it, because this is the part of the planet where we look at water in its solid state. It's in its liquid state also, but you've got solid water interacting with other states of water. And you've got quite a heavy ratio of solid water existing and frozen ground existing. And that's what this permafrost means here. Perma meaning always occurring. Permanent is the word that it comes from. And frost meaning frozen. You are sub-freezing, 32 degrees Fahrenheit or 0 Celsius, that or below. And there are areas on the planet at the poles, the North Pole and Antarctica, that have permafrost. They never get above, they never thaw out. In other words, they never thaw out. And so that's the ground. When we refer to permafrost, we're not so much talking about the ice layer on top of the earth and the soil and the rocks. We're talking about the earth and the soil and the rocks and the water content within those, because remember, water is sticky. And so if it can seep down into there, it's going to condense or to latch hold of the molecules of dirt and rocks, and it's going to saturate them, a saturation level. And in the permafrost, that saturation level is always in the solid state and not the liquid state or the vapor state, like we learned about precip happening when saturation is reached in an air mass. And so this graphic and these vocabulary terms on the board behind me in this graphic are particular to the cryosphere, or the ice that exists on the planet. In some of the videos that we're going to look at, the curated videos that we're going to look at next, there will be some information about Antarctica and the ice content there and the movement of glaciers, for instance. Glaciers move. You might have learned that way back in the 5th grade. They migrate and they build up more ice behind them, and they migrate and they melt off and break off into the ocean, and that's part of the water cycle. So the water cycle is constantly in motion. And even though glaciers creep at a teeny tiny rate per year, I can't remember how many millimeters or centimeters it is. Somebody look that up and post it on the discussion board for me, please. But anyway, they creep at a very small, millimeter rate per year or even decade. They eventually degrade, break off, melt, sublimate. Quite often, sublimation is a major process that affects glaciers in all over the world where glaciers exist. And so these processes too are part of the hydrosphere, not just going from that liquid to vapor state, but going from that vapor to solid deposition. In other words, vapor to solid, like snow or ice falling and staying snow or ice, never melting into that liquid state and becoming part of this never-ending cycle. Okay, so there are some curated videos that you're required to watch and take notes on. If you didn't stop me while I was speaking, speed speaking just now with all these vocabulary terms, if you didn't stop me and take at least an outline of notes so that you can go back to the textbook and fill in definitions and explanations, or rewind my video and fill in definitions and explanations, then do that now. That's the process of active note taking that you're required to do. And when I ask you to cite information from your notes, this is where you are supposed to go. Whatever you've typed out or written out longhand from these videos when I ask you to cite your notes, so whether it's from a curated video or from me talking to you about the topics we're going to cover, that's the important stuff. Okay, and so I've got another video that I want you to watch before we go to the curated videos, because I'm going to give you some suggestions on what you can do for an outside source reflection journal for this particular set of lessons, if you're interested. So watch for that video from me, and I will see you then.